Okay guys, so this is the next section, which has a couple more identity formulas for us to use. Okay, so we're going to be using the sum and difference formulas for sine and cosine, and then we're going to be using the double angle identities for sine and cosine. Now I know there's a lot of other identities on that sheet. We're not going to get to them just because you're not really going to see them a lot. Like when you take calc, so I don't really see the need to go over them. So yeah, that's my thinking for that. So this first one is called the composite identity for cosine, which essentially means it's the sum and difference formulas for cosine. Okay, so if you happen to be adding or subtracting two angles, okay, we're going to say that x is the first angle, right? So this is the first, and then y is the second angle. Okay, so if you look at your formulas, it's cosine of the first angle times cosine of the second angle minus sine of the first, sine of the second. Okay. And then if you're subtracting the two angles, then it's just cosine of the first, cosine of the second, plus sine of the first, sine of the second. Okay, so it's pretty straightforward. As long as you know what two angles that you're using, then you just apply it to the identity. So it expands out. You can go from left to the right side, or you can, if you happen to, have a product like this, you can work your way back to get the cosine of x plus y or x minus y. So the first example says find the exact value of cosine of pi over 12. Okay, now pi over 12 obviously is not on the unit circle. I understand that, but what we can do is we're going to find two angles that are on the unit circle that either add or subtract to give you pi over 12. Okay. So think of the angles that we have on the unit circle, right? You have pi over 6, which is 2 pi over 12, right? We're going to need common denominators. You have pi over 4, which would be 3 pi over 12. Okay, you have pi over 3, which would be 4 pi over 12. Okay, and then another one would be like pi over 2, which is then 6 pi over 12. Okay, so I need two angles to either add or subtract to give me 1 pi over 12. Okay, now there's a bunch of different ways you can do this. You don't have to do it the same way that I do it, but we should get the same answer at the end. Okay. So what I'm going to do is I'm going to choose, say, I'm going to choose pi over 4, and I'm going to choose pi over 6 as the two angles that I do. Okay, so if I do 3 pi over 12 minus 2 pi over 12, it gives me 1 pi over 12. Okay, so the two angles that I'm going to use here are going to be pi over 6 and pi over 4. Okay, so how I'm going to write this now is going to be cosine of pi over 4 minus pi over 6 gives me cosine of pi over 12. All right. So because we're subtracting the two angles, we're going to use the difference formula for cosine. Okay, so that's the second one here we have in the list. Okay, so this is going to be cosine of the first angle, cosine of the second angle, plus sine of the first angle, sine of the second angle. Okay, so that's using the identity. Right, you're expanding it out. Now you have things that you can work with. Okay, so you know that cosine of pi over 4 is going to be root 2 over 2. Pi over 6 is root 3 over 2. And then we got root 2 over 2 and then pi over 6 is 1/2. All right, and then all you do from there is you just simplify. So you have root 6 over 4 plus root 2 over 4. And then when you combine them together, you can just leave it as root 6 plus root 2 over 4. Okay, so that would be your exact answer to that problem. Now you can plug it into the calculator if you want, and that'll give you your decimal answer. But this is perfectly fine. Okay. Now I could have done it another way. I could have done I could have picked two different angles. Maybe could have done pi over 3 and pi over 4. That also would give me pi over 12. I would still get the same answer. Okay. So actually what I'm going to do, I'm going to copy this, and I'm going to move it down here. All right, so now what I have to do is I need to come up with two angles that either add or subtract to give me 7 pi over 12. Okay. So what I could do, right, is I could use pi over 4, and then I could also use pi over 3, right? So cosine of pi over 3 plus pi over 4 is going to give me cosine of 7 pi over 12, okay? So now since we're adding the two numbers together, I'm going to use the addition formula for cosine, all right? So that's cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay. Now with addition, that the order doesn't really matter. If it's okay if you did pi over 4 first and then did pi over 3, but you should still get the same answer. So cosine of pi over 3 is 1/2. And then root 2 over 2 minus pi over 3 is root 3 over 2. And then root 2 over 2. Okay, so now I got root 2 over 4 minus root 6 over 4. And then if you put them together, root 2 minus root 6 over 4. Okay? So that's how you use the sum and difference formulas, all right? So it's just, again, coming up with two angles that either add or subtract to the one that you want. Okay, and then number 3 gives us some information, gives us sine of A and then sine of B, and it says find the exact value of cosine of A plus B. Okay, so if I'm going to do cosine of A plus B, right, I know that that's going to be cosine of A, cosine of B, minus sine of A, sine of B, right? So that's just using the sum formula for cosine, right? So that would be the first one here in the list, okay? So in order to solve this, right, I have sine of A and sine of B, but I don't have cosine of A or cosine of B, okay? So we need to figure those out first, all right? So draw it out to help you come up with the answer. So it says that A has to be between pi over 2 and pi, okay? So think about where would that go if it's between pi over 2 and pi over 2 and pi. Well, it's got to go then in quadrant 2, okay? So draw out your triangle. All right, now it says sine of A is 4 over 5. So if I make A the angle right there, okay, 4 over 5 would make this 4, and then that's 5, okay? And then, now because it's in the second quadrant, I know that x has to be negative, okay? So if you solve that out, right, you got x squared plus 4 squared is 5 squared. So that's x squared plus 16 equals 25, and then x squared equals 9, so then x must be plus or minus 3. All right, now because it's in quadrant 2, we're going to make it negative 3. Okay, so then what is now cosine of a? All right, now cosine is x over r, so you got negative 3 over 5. Okay, now you're going to do the same thing for the second one. All right, so sine of b is negative 2 root 5 over 5, and that's between pi and 3 pi over 2. So pi and 3 pi over 2. All right, so it's got to be in quadrant 3. All right, we're going to call that b. All right, now it says sine of b is negative 2 root 5, so negative 2 root 5 over 5, right? Now I know that this side is negative 2 root 5 because we know that the radius is always positive, right? So now again, you just need to figure out what x is. So x in this case is also going to be negative. So we got x squared plus negative 2 root 5 squared equals 5 squared. So we got x squared plus, that's 4, that's 20, equals 25. So then x squared equals 5. X is plus or minus 5. Root 5, sorry. So then this must be negative root 5. Okay, so what is now cosine of b? Okay, so that's going to be the x term over the radius. All right, so I'm going to need this, and I'm going to need that to solve my problem. Okay, so cosine of a, we figured out was negative 3 over 5, and then cosine of b is negative root 5 over 5, okay? Minus sine of a. Sine of a we said was 4 over 5, and then sine of b is negative 2 root 5 over 5. Okay, so this becomes now 3 root 5 over 25, okay, plus 8 root 5 over 25, and then that final answer would give you 11 root 5 over 25. Okay. So again, you got to, when, it gives you these two cases problems, you need to kind of draw it out so you know exactly what you're solving for. Okay. So the next examples are for the sum and difference formulas now for sine. Now it's very similar, except it's the difference is where the sine and the cosine go. So if you're looking at sine of x plus y, okay, so it's sine of the first times cosine of the second plus sine of the second cosine of the first, all right? And then the difference formula is just the opposite of that. Sine of the first, cosine of the second, minus sine of the second, cosine of the first, all right? So again, you just need to identify which two angles you want to call your first and your second, okay? So now, again, for this one, we got 35 pi over 12. Okay, so I'm going to bring this back. So 35 pi over 12. Okay, so I need, again, two things that either add or subtract to give me 35 pi over 12. Okay, so obviously none of these on the screen are going to give you 35 pi over 12, right? But we can use multiples of these, right? Now, if, say, for example, I were to multiply this one by 5, right? That's going to give me 20 pi over 12, right? Now, how much more would I need to get me to 35 pi over 12? Well, I would need 15 pi over 12, okay? How can I get 15 pi over 12? All right, well, if I multiply this by 5, that's going to give me 15 pi over 12, right? Now, since I multiplied both of those fractions by 5, I need to multiply these by 5. Okay, so that's going to give me 5 pi over 4 and 5 pi over 3. Okay, so those are the two angles that we're going to use to get 35 pi over 12. All right, so 5 pi over 4 plus 5 pi over 3 is going to give you 35 pi over 12. All right, so you got sine of 5 pi over 4 plus 5 pi over 3 is going to give you sine of 35 pi over 12. Okay, so first thing you got to do, again, is just expand the formula out. So you got sine of 5 pi over 4, so sine of the first times cosine of the second, plus now sine of the second, cosine of the first. All right, so now you just need to come up with your values. So you're doing sine of 5 pi over 4, all right, which is negative root 2 over 2, cosine of 5 pi over 3, which is 1/2, plus sine of 5 pi over 3, which is negative root 3 over 2, and then cosine of 5 pi over 4 is negative root 2 over 2. So you got negative root 2 over 4 plus root 6 over 4. So your final answer would be negative root 2 plus root 6 over 4. All right, very similar to the cosine problem above. Okay, now for number 5, it says, given that sine of A is 3/4 and cosine of B is negative 5 over 13, where A and B are both in quadrant 2, find the exact value of sine of A plus B. Okay, so sine of A plus B is going to be sine of the first, cosine of the second, plus sine of the second, cosine of the first, right? So that's your formula that you're going to use, right? Now we need to figure out what all those ratios are going to be, okay? So if you draw the first one, all right, you know that so if we're going to say this is A, right? We say that this is 3, and then this is going to be 4, okay? Now, if you do Pythagorean Theorem, you'll eventually get that the missing side is going to be root 7, okay? Now, because it's in the second quadrant, you just make it negative, okay? So if we know sine of A is 3/4, then cosine of A is going to be negative root 7 over 4, okay? And then you do the same thing for the next one. So for B, which is also in quadrant 2, all right, it says this is negative 5 over 13, okay? Now, if you do Pythagorean Theorem, you'll figure out that this side here is 12, all right? And it's positive 12 because it's in the second quadrant. So sine of B now is just going to be 12 over 13, okay? So we're going to need this, and we're going to need that. All right, so sine of A is 3/4, and then cosine of B we know is negative 5 over 13 plus Sine of B we know is 12/13. And then cosine of A we figured out was negative root 7/4. Okay, so this is going to be negative 15/52. Okay, minus 12√7/52. So if you put them together, you got negative 15 minus 12√7/52. All right, so again, make sure you guys you're drawing the triangles out to come up with the solutions. Okay, and then give you a couple identities that we have to prove now. Okay, so this first one says sine of 3 pi minus x equals sine of x. All right, so the left side, because I'm subtracting the two things, I'm going to use the difference formula for sine to expand it out. So it's going to be sine of the first. Okay, so we're going to call this angle, this is the first, and then x is we're going to say is the second. Okay, so it's sine of the first, cosine of the second, minus sine of the second times cosine of the first. Okay, now sine of 3 pi, okay, is the same thing as sine of 1 pi, which is actually just 0. So you got 0 times cosine minus sine of x. Cosine of 3 pi is really just negative 1. All right, so again, just look at your unit circle to come up with those values. All right, so this second part is just going to go away, and then negative sine times negative 1 is just sine. Okay, so you have your proof. And then for the second one, okay, so again, I'm going to do the left side. I'm going to expand both of these out. So it's going to be sine of the first, cosine of the second, minus sine of the second, cosine of the first. Okay, and then I'll do this in a different color. So then this is going to be plus sine of the first, cosine of the second, plus sine of the second, cosine of the first. Okay. All right, now you should be able to cancel something. So I got sine of y, cosine of x, and then I got sine of y, cosine of x. All right, so those are going to cancel. And then if I put sine of x cosine of y plus sine of x cosine of y, you have 2 sine of x cosine of y. Okay? And then you're done. All right? So that's how you guys are going to use your sum and difference formulas for cosine and sine. And then the next video, I'll talk about double angles for sine and cosine.